Okie dokie. Here we go. We're on lesson 3.2a. And what we have here is we are talking about predictions using a linear regression line. Woo-hoo-hoo. All right. Or an equation to predict the different values, finding residuals, and interpreting a regression line. Okay, so without further ado, when you go to your calculators, your TI-84s, your TI-Inspires, or whatnot, there are two different lines they have there. They will have a y equals ax plus b, or they'll have this snazzy dandy one right there. Both give you pretty much the same values, except we always have this one right here for statistics, where we have the a is first, the y-intercept, the b is a slope, and then we have y. Now, be very, very important that you identify what y is, and that's a predicted value, and we put a hat on there. So that's called y hat. That's our predicted value. So from here, we have to be careful because of extrapolation. We talked about extrapolation. If you've gone through other studies or seen or didn't read it in the book, extrapolation is where we go beyond the data set that you have. So if you have a bunch of data, and let's just say this goes from 1 to 10 seconds. I know, I'm just making something up. 10 seconds, and that's a last data point. Well, extrapolation is that we're going to, what happens if we go to 12 seconds or 20 seconds? All right, as we get farther and farther from our data points, we realize that our line may not be as predictable. It may not give us prediction that is really good. And so that's what's called extrapolation. We do not want to extrapolate. We want to stay within our data range. So, additional to that is we have talked about residuals. Residuals are the difference between the actual value and the predicted value. So we call it R equals AP. If you remember that, A minus P, AP. All right, so actual minus predicted. How we can define or interpret a residual is the actual Y in context was this many residuals higher or lower than the predicted value for whatever X value you're looking for. Okay, so if you have an actual value, so if you have a residual that's positive, that means the actual value is larger, all right, than the predicted value, all right. So the actual value in context was higher than the predicted value for whatever value you're looking at. If you have a negative value, obviously the predicted value is going to be lower, all right, or sorry, it's going to be greater than the actual, so the actual value was lower than predicted if it's going to be negative. So just think about this when you're going through and doing that. All right. When we talk about interpreting the y-intercept and slope, you might have did this in Algebra 1, but the y-intercept is when x equals 0, and we want to put that in context. Because I tell all my students, all right, numbers mean something. Numbers mean something, and we want to give context to what the meaning of these things are. So when we talk about y-intercepts, well, when x is 0, the predicted y in context is the y-intercept. That's what we have right there. All right. So when is y 0, what is that y predicted value going to be? When you have a slope, all right, the slope is with each additional x in context, so that's rise over run. So as x increases in context, the predicted, now this is very, very different than what you do in algebra, the predicted y value increases or decreases by whatever the slope is. So if the slope is positive, it increases. If the slope is negative, it will decrease. So it's very important that you remember two different things when you're talking about slope, is that we do not want to just put our slope in there and put a negative value, but we want to say if it increases or decreases, give it context, but also state that it's a prediction. We're looking for a prediction there. All right. Well, that is the notes for this 3.2a. I'm going to come back for another video with some examples. All right.